Alright, so now today what we're going to be doing is we're going to be learning about how to find the zeros of a function and the axis of symmetry. So everyone knows what the axis of symmetry is, right? It's that imaginary line that cuts our parabola in half. Yep, so now zeros, we haven't talked about that much, but we're going to now. So when I say we're going to find the zero of a function, I mean that we're going to find a value for x, that when we plug it into our function, we get 0 out of it. So an x value, when we are finished doing our math, our y value is going to be 0. So an x value that makes our function equal to, what do you guys think this is?
0.
0, that's right. So here's a little visual for you guys. So for this quadratic here that I drew, what are the what are the x values that make this function 0? No. So x values that when, after we plug them in, the y value is 0. So any x that has a y value of 0. Ricky?
Would that be like anything on the inside of the parabola? Right there on the axis?
Well, you're close. It would be any point that's on our x-axis. So wherever.
That's what I was trying to say.
Okay, yeah. So wherever our graph either crosses or touches the x-axis, those would be our zeros. So
Oh, then
how many zeros does this one have?
2.
Right. So do you guys know of any other situations where we might not have 2 zeros? Christian? Or are there other ways that we could have zeros?
The parabola is only on the x-axis.
So, kind of like this, but closer to it?
Yeah.
So it just touches it like right there?
Yeah.
Okay, there's one. How about one more? Isaiah? Okay.
You said that.
Morgan?
No zeros?
Well, what would that look like then if there are no zeros?
Well, what are you asking us for?
Are there other ways that there could be zeros? Morgan? So here's this, our coordinates, so like something like that where it doesn't touch the x-axis. So how many zeros does this one have? 0, because it doesn't touch across the x-axis. This one has 1, this one has 2. So just from those we can say that any quadratic, there's a possibility of having 0, 1, or 2 zeros.
Could it ever have 3?
Nope, not for a quadratic.
What if it was sideways and one line was going all the way through?
That wouldn't be a quadratic function. But, alright, now, to find the zeros on a graph, just like on here or this one, we're going to be looking for the x-intercepts, but we're not going to put the ordered pair that would be. So I want you to underline this one right there. We're going to look for the x values of the x-intercepts. So when we're looking at a graph, we can find the x-intercepts, but it's not going to be the ordered pair that it is. It's only going to be the x value that it is. So for instance, if we had an x-intercept of 2, 0, our 0 would just be 2, the x value of it. All right, now everyone open your books, page 531. All right, and we are going to be doing the 2 check it out problems on the bottom of there. So it says, find the zeros of each quadratic function from its graph. Then after we find it, we have to check it. Explain that, but right now we're just going to be dealing with number 1A. So looking at that graph, what would the zeros be if there were any? Actually, that's a little confusing. Are there zeros on it?
Yes. No,
Why?
because it's not touching the x-axis.
Right, it's not touching it, it's not crossing it, so, just like the question says, is the graph crossing the x-axis or touching it? Since it doesn't touch it or cross it, you can say that there are no zeros for 1A. Alright then, 1B. What would, or someone tell me what the zero of that one would be. Or here's another question, is it touching it or crossing the x-axis? Which one?
Touching it.
Touching it, so how many zeros would we have? 1, so there's 1 0. And Carly, do you know what the value of the 0 is?
3, 0.
No,
What?
that's the x-intercept.
So what do you want?
We just want the value of our,
3.
yes, there you go. So the difference between 0 and x-intercept is a little tricky.
So,
So 0 is just one number by itself, x-intercept is an ordered pair.
okay.
So we have 1 0, yes, Riley? Alright, so we think our 0 is 3. In order to be sure, we can just plug it into our equation. So we have y equals, substitute in for x. So then, what's 3 squared? 9. So y equals 9. 6 times 3 is 18 plus 9.
So the 9's cancel out.
What's 9 minus 18?
0.
No.
And 0?
So, just doing this one step at a time, Ricky. Negative 9 plus 9 is?
0.
0.
So, after we've gone through checking it out, we can say that 3 is a 0. Yes, Blaine?
I was just adding 9 and the other 9 again and subtracting
Okay. So you can do that too. Yeah, this is just how I went through it, so. Whatever works for you and you get the right answer, that's fine. Alright, now, when there is only 1 0, it is the vertex of our parabola. Just like in this example here, right there, that's the only 0. So what is the only point on a parabola that has no symmetrical point with it? That's a weird question.
Say that again.
So there's only one point on a parabola that doesn't have a reflection with it.
the vertex.
So it's the vertex. So like this one right here, if we have our axis of symmetry, we can reflect it over itself, right? There's only one point that doesn't have a partner that it can
Oh.
flip onto.
Right.
Alright.
I got you.
Because it's like so thin, it's not even a point.
All right, and then when there are 2 zeros, go Bison.
What?
I don't know anything about that.
Wait, does that mean bisons are zeros?
No, when there are 2 zeros,
Mess the boogie.
the x value of our vertex is going to be halfway in between our zeros. So this one here, we have 2 zeros. The x value of our vertex is going to be halfway in between them. So here's our vertex, it's going to be halfway in between both of them.
Ooh.
All
Will
right.
that always be true?
Mhm.
Oh.
Blaine.
Oh, I missed the question.
Okay. Got your hand up. Alright, so any questions so far? So what's the difference between a 0 and an x-intercept?
One's gonna repair the other. Which one?
Right, so Christine said one's an ordered pair, and one is just a number. So Carly, which one's which?
X-intercept is an order pair,
Mm-hmm.
and then X value.
Is a 0.
Yeah.
Alright. So we can move right along. Alright, now we're getting back into familiar territory. So the imaginary line that divides the parabola into two symmetrical halves is called what? Axis of symmetry or line of symmetry. Alright, here's a couple things about them, about the axis of symmetry. First, it is always, everyone say always, always gonna pass through the vertex of the parabola.
What happens if it doesn't?
Then it's not a quadratic.
Ooh.
Alright, so it's always going to pass through our vertex. There are two ways we can go about finding it. One, we can just use the vertex of it, of our parabola. So if we have the vertex, we can find the axis of symmetry because it's going to go right through it. And the other way we can find it is by using the zeros of the function. So if we have two zeros, just like it said on the front page, it's going to be halfway in between both of them. Alright, so back to this example here on the board. This is what the axis of symmetry would look like. Except someone's probably a better artist, so it will probably look better, but this is dividing it right in half, right? So what kind of line is this axis of symmetry?
Symmetrical?
Linear.
It starts with a V.
Vertex?
No.
Vertical.
Vertical. It's a vertical line, right? So when we were going back a long time ago, when we were describing writing equations for linear functions, when we had vertical lines, how did we write those out? Give you a hint. It starts with x. X equals something, right? So like if I said x equals 2, we would have a vertical line on the x value 2. So any point on here should have an x value of 2, right? So when we're finding our axis of symmetry, what do you think you have to write it out as? X equals whatever our axis of symmetry is, right? So like on your homework, if you're asked to find the axis of symmetry, which you will be, you're going to say either axis of symmetry, x equals whatever number it is. Okay? Alright, then there's one last thing about it. If you just want to find it from the function, you can use the formula x equals negative b over 2a. So, does anyone think they know where they got that a and b from? Here's another question. What's the standard form for a quadratic equation? Ax squared plus bx plus c. So they have an a value and a b value. So when we're given a function, we can just take the a and b value, plug it right in there. And then once we plug that in, that will give us the x value for our axis of symmetry. Yes?
Wouldn't this equation not be a quadratic equation? I don't know.
No, this is just a way to find the axis of symmetry for it. We would have a quadratic that we would take our a and b from.
And then what is it that equation? I'm
Get into
confused.
that equation, it's a formula, it's just not a quadratic equation, but it is an equation, it's a formula. It will help you find the axis of symmetry. Before you move on, I want to go to your drawing right here, Mr. Conlon, and I want to say that the vertex of this parabola is negative, or not negative, 3, sorry, positive 3, -5. That's its vertex, okay? So you tell me, what's the axis of symmetry for that parabola? Axis of symmetry, everybody think about, what would be the axis of symmetry for the parabola drawn on the whiteboard, given that it is a vertical line, imaginary vertical line cutting that parabola in two symmetric halves? Riley, what do you think?
-5.
No? Harley? 3? No? Morgan? Oh, you were gonna say x equals 3. Oh, so the axis of symmetry has the equation x equals 3, not just 3, right? Okay, so x equals 3 would be the equation of the axis of symmetry in this one. So you were close, Carly, you just forgot the x equals. Now you're ready to move on to what's gonna happen next.
All right, you guys can turn the page in your books, 532. So we're gonna be doing, check it out, number 2. And so 2a, it says, find the axis of symmetry of each parabola. So looking at that problem right there, what do they give us there? Do they give us the zeros or the vertex? Say that again, Blaine? The vertex. So they give us the 1 point, it's right at the bottom, so that looks like the vertex. So what is the coordinates of that vertex? Riley?
-3, 0.
-3, 0. So we have -3, 0. That's our vertex. So we know that the axis of symmetry passes through it. Always does. So our axis of symmetry has the equation x equals
-3.
what? Blaine, because you raised your hand. -3, thank you. Alright, so that's that one. Moving on to 2b. For this one, do they give us the vertex or the zeros of that function? They give us the zeros, right? And what are they? Riley?
-2 and
-2 and 4.
4.
So everyone see where Riley got that? They have those 2 points, -2, 0 and 4, 0. So he's taking the x values of both of those points, and those are the zeros of our function. Yes, Isaiah?
Isn't it supposed to be x equals -2 x squared?
Nope. So when we're looking for the zeros of a function, we can just say that the zeros are -2 and 4. Because if we say that, we can just say if you plug in -2 or 4 into our function, you should get 0 out of it. Alright, so they gave us the zeros. When we are given zeros, we have to find the halfway point between them, because that's what our vertex would equal. So if we want to find the halfway point between -2 and 4, what do you think we would do? Riley?
You would do -2 plus 4 over 2.
So -2 plus 4 over 2. So -2 plus 4, that's you just putting together the whole distance of it. So like if we went up here on the number line, we have -2 and 4. Once the whole thing, so we add them together. And dividing by 2, that would give us the halfway point, right? Alright, so upstairs, -2 plus 4 is
2.
+2. We still have a 2 downstairs.
1.
So 2 over 2 is 1.
1.
Alright, now, what did we just find? We found the x value of something, right? And what is it?
Ricky, raise your hand.
Ricky?
Okay, so if you draw a line from the vertex down, it would be exactly at 1.
Alright, so could we say x equals 1?
Yes.
This would be our line of symmetry. So we found the halfway point between our two zeros. And if we would draw a line through that, we would get our vertex on our graph as well. So this right here, this is the axis of symmetry's line for 2b. Alright, last little part here.
Isaiah?
Yes.
So we only have to do x equals 1 for like when we're doing the axis of symmetry.
Yes. Whenever you're doing the axis of symmetry, you have to have x equals something. So, alright, next one. If a function doesn't have any zeros, like if you have a graph of it and it's asking you to find the axis of symmetry, but it doesn't have any zeros, it's a little harder to do that when using the way we just did it. Or sometimes when you're given a graph, it's just really, really hard to say, oh, it's exactly this point or it's exactly that point. So this is,
Sometimes you're just given the equation.
yeah, sometimes that happens, and then you have to find the axis of symmetry that way. That is where that formula that we had up here comes into play. So, just on the other page, 533, that last check it out one, number 3. What is that asking again? Find the axis of symmetry of the graph of y equals 2x squared plus x plus 3. So we have that right here. And if we go back up to that formula right there, they have an a and b in there, right? So what do you think we should find for this one right there? A, B. We could find C, but we don't really need to. So what would A be for this one? 2, B is 1, C is 3, but we don't need to worry about C right now. Alright, so the formula to find the axis of symmetry is negative b over 2a. So this is a general look for it. Then we just substitute in all, or a and b into it. So we have x equals, a negative is out there by itself. Negative 1, 2 times substitute 2 in for a. So when we get everything cleaned up, what do we get, Riley?
Negative 1 over 4.
So we have x equals negative 1 upstairs, 4 downstairs. So what's the axis of symmetry for this one here?
Negative 1.
Negative 1/4, that's right. X equals negative 1/4.
And that's the line of symmetry.
Yep, that is the line of symmetry. Either one's fine. Yep.
Will this be what we have to do on our homework?
Mm-hmm. Alright, so anyone have any questions about anything that we went over today? So what's the difference between 0 and x-intercept again?
Why is
X-intercept.
Half. The difference is half.
Isaiah?
the x-intercept is the x-intercept is a ordered pair and ordered pair, and
Zero.
the other one,
X value.
yeah, that thing is just a number.
Alright, so x-intercepts, raise your hand. X-intercepts are ordered pairs, so it's some x value like 2, comma 0. The 0 of that one would just be the number 2. So that's the difference.